Hello and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will take a look at a problem from section 9.6, means. This is problem number 3. It says that the average number of accidents at controlled intersections per year is 4.5. Is this average less for intersections with cameras installed? So there was a study of 64 randomly observed intersections with cameras installed and had an average of 4.1 accidents per year. And then the standard deviation for that sample is 1.18. What could be concluded at the alpha is equal to 0.01 significance level? All right, first of all, what kind of study are we dealing with? So we are, first of all, dealing with looking at the average number of accidents. So we must be dealing with the mean. We are dealing with one population, but that's all of Chapter 9, just one population. We'll see later on in Chapter 10, we'll be dealing with two populations. So mean, let's say one mean, and we are looking, as I look through this information, I don't see anything about the population standard deviation being given. So no, or I'll say the standard deviation sigma, population standard deviation sigma is not given or not known. So we will be using a t-test. So here is a t-test for a population mean. All right. Okay, now let's go back and read through the information. Here we have the mean is 4.5. Is this average less for intersections with cameras? And so they actually did a test for cameras. So I will have to say that the claim here is that the mean is actually less than the regular average for intersections, regular number of accidents per intersection. So the claim should be less than that. Now, this does not contain a condition of equality, so that is going to have to go to the alternative hypothesis, which means the null hypothesis. So we'll call this the HA. So the null hypothesis, which we'll call H naught, will have to be the opposite of this. So the opposite of this is bigger than or equal to 4.5. Now, if we try to look for this symbol may or may not exist here. Let's start with the alternative hypothesis, since that was given as a claim. We'll say mu, I'll just say mu is less than 4.5. All right, so then your null hypothesis is mu is bigger than or equal to. Now, if the bigger than or equal to does not exist, a lot of times people just say equal to, since that is what we're going to be testing. And if it fits there, then we fail to reject the null hypothesis. But if we do reject that, then we're probably looking at this being less than. So in any case, your mu is still going to be 4.5. Okay? All right. So that is your claim, and your hypotheses are set up. So we can move on to the next question and finding the test statistic. Now, since this is going to be a t-test statistic, we will use the variable t, and our t is going to be x bar minus mu divided by, and remember the standard deviation for your t distribution is going to be s divided by square root of n. So that's your whole denominator. Now, in the calculator, you probably wouldn't need to do this because it would just do it automatically for you. But if we're using Google Sheets, we actually have to get this set up, and likewise for the p-value. So let's go through this one by one. Let's do the test statistic first, and let's examine how it's going to look like in your Google Sheets. So I actually set up a template for Google Sheets for a t-test when we're doing the test if you're given a set of statistics. And if you're given a set of statistics, you need to know what the null hypothesis is given as. You need to identify what kind of tail we're using, so you can get that from the alternative hypothesis. And we need to know the sample mean, standard deviation, and the sample size. And the thing about this is that once this gets fixed up, then it'll automatically spit out the results for your test statistic and your p-value. But your test statistic here is given by these formulas. So first it's given by C4, that's C4, and that's the sample mean, minus C2, and that is the mu that's given. So that's the x bar minus mu. And then we're dividing this by C5, which is the sample standard deviation, divided by the square root of C6, which is the sample size. So that is exactly this formula that's being given here. Okay, and so we will run through this and compute our test statistic using this Google Sheets. Oh, we do need to identify our other pieces of information here. Let's come back to the top and identify our sample mean, sample standard deviation, and sample size. So your sample mean is going to be x bar, and that is for the 64 intersections where they have those cameras. The average there, the sample mean is 4.1. Your sample standard deviation was given as 1.18, and then your sample size was the first thing given, and that is 64. So we'll use these pieces of information to put into our Google Sheets, and then again these calculations will automatically be done for you. So we have 4.5 for the mu. We are looking at the alternative hypothesis, and if I look at the alternative hypothesis, I see that it's a less than sign, so that is a left tail. So I'll put a -1 for the left tail. The sample mean was 4.1. The sample standard deviation was 1.18, and the sample size was 64. Okay, and once we press that, we get our results. So first, our test statistic result is 2.7118. Maybe we'll call that, well, they said 3 decimal places, so -2.712. So we will write that down for our answer. Again, this is a t-test statistic because we're doing a t-test, and this is equal to -2.7118 or 12. Now, after we have that, they want us to find our p-value. So imagine this going into your t-distribution. This is your t-distribution. And this is your standard t-distribution centered at 0. And then our value here was 2.712 negative. And so we're looking for this area under the t-distribution that is to the left of that. So in finding this area, this is your p-value, this area. And that on our Google Sheets will be given by t.dist. And then we put in the -2.712, comma, and then our degrees of freedom is 63, comma, and then true, because this is going to be the cumulative question. So 63. Now let's write it a little bit neater. 63, and true. So remember these commands, or what these commands are. This is your X component that's coming here. Technically it should be T. This is your DF, degrees of freedom, and this is asking, is this cumulative or not? Okay, and we have this all set up here. It actually is 0.0043. We want 4 decimal places, 0.0043 it is. So your p-value is 0.0043, which is quite small. And we can see clearly that the p-value is, PV is less than our significance level. And remember that when it's less than significance level, we reject the null hypothesis. So based on this, we should reject the null hypothesis, H naught. And so the conclusion, if we rejected the null hypothesis, so we rejected this null hypothesis, then we should be able to support that claim. So the data suggests sample is not significantly less. Well, it is significantly less, so let's go ahead and cross this out for now. We know that this is not it. Suggests that the population mean is not significantly less than this. I think we want it to be saying that it is significantly less, so let's cross that out as well. It suggests that the population mean is significantly less, so this is a good one. So there's a statistically significant evidence to conclude that the population mean number of accidents per year at intersections with cameras installed is actually less than 4.5. So let's go ahead and choose that. All right, next one, we're going to interpret the p-value. So the p-value in this context is saying what is the probability that we collected this thing and the mean is 4.1, or the mean would be less than 4.1. So the first one, if the population mean, or if the population mean number of accidents per year intersection is 4.5, and if another 64 intersections with cameras installed, then there would be a 0.43 percent chance that the population mean will be less than 445 or 4.5. So they got that number from our p-value. If you move the decimal place a couple of times, it's 0.43%. And so that's how they got this number, 4.3%. However, this particular p-value is related to the actual mean for the sample that we collected. So I don't think it would be this one because it says 4.5. Let's read the next one. If the population mean number of accidents with cameras installed is 4.5 and we collected 64 intersections and observed that there would be a 0.43% chance that a sample mean installed with cameras installed would be less than 4.1. So this is it. This is the one specific to the sample that we collected, and that specific sample, there is a 0.43 chance, or 0.43% chance, that's really small, that we get this to be less than 4.1. And so that is your choice for this one. This is what the probability value means. This is what the p-value means. We don't need to look at the rest, but if we look at it, there's this chance, this is the p-value again, that the population mean number of accidents is less than 4.5. That's not really what that's saying. We need to include in the statement the sample size that we're collecting and the fact that this is going to be less than 4.1. The last one says it's a type 1 error, and that is not correct. The p-value is not the type 1 error. The type 1 error is actually alpha. So type 1 error is actually equal to alpha, and that's not what the p-value is. The p-value is smaller than that. So the last one, it says interpret the significance level in the context of the study. Well, I would be happy to choose if any of these choices says that there's the type 1 error is 0.1 or I'm sorry, 0.01 or 1%, but I don't see that as any of the choices. So let's figure out how to interpret the actual p-value. So here, if the population mean number of accidents with cameras installed is 4.5, another 64 intersections with cameras installed observations would be a 1% chance that they would end up falsely concluding. So remember, this is a type 1 error. Falsely concluding that a population mean number of accidents per year with cameras installed is actually less than 4.5. So this is almost saying that we're rejecting. Let's reinterpret the type 1 error. So reject the null hypothesis when it is actually true. And I think that's what this first one is saying. So I think the answer is going to be the first one. But let's look through the others. There's a 1% chance of the population mean number of accidents, so that's not going to be it. So let's cross that one out. 1% chance that you get into a car accident, so please wear seatbelts. Let's cross that. If the population mean number of accidents with cameras installed is less than 4.5, another 64 intersections with cameras installed are observed, then there would be 1% chance that we would end up falsely concluding that the population mean number of accidents with the cameras installed is equal to 4.5. So I don't think we're dealing with the equal sign here because of the alternative hypothesis. And so I think we do want to stick with that first one. And this first one would be the interpretation of the type 1 error alpha, and that is your significance level. All right, that's the problem, and just try to go through all these things. Now, if you were to use a calculator, the p-value and the test statistic would be given to you when you put it in, but I will make this available as a template for you to fill in all this information up on top and then get the results in the bottom. And there'll be another version of this where you actually have to, well, you can just type in the data and then you can get the same results. But this particular problem didn't have the data, it just had the statistics, so these are the calculations for the statistics. Okay, I hope that helps. Good luck.